right? According to the question, like we have like cerussita as an ore of lead, right? So here it says it contains 68% of lead 2 carbonate. So firstly, we'll write the chemical formula for lead 2 carbonate. So the lead, the charge here is written here, it should be 2 plus, right? And for the carbonate, it should be CO3 2 minus. If we do the cross method, then we should be able to derive as like Pb2 CO3 brackets 2, right? But now, if we want to simplify it, we can just directly put it into 1. This one will be PbCO3 here. Alright, and then we continue to read the question. Assuming that the other compounds do not contain lead, what is the mass of ore required to extract 29.1 grams of lead? So it asks what is the mass of ore. Let's like letters start with C. This is a name I can't read though. So how many mass of the ore and required to extract 29.1 grams of lead? Very interestingly, it has like 68.0% of like lead carbonate, right? Can we do a formula of number of moles here first? So for example, here we already have the mass for lead, right? We should be able to calculate its moles, right? Always calculate the moles. The mass should be 29.1. What is, I should write the formula here, sorry. The mole should be mass over molar mass, right? What is the mass for the lead? It should be 29.1 gram. What's the molar mass for lead? It should be, is it written in the question? Yes. So Pb equals to 207.2 gram per mole, right? If we try to calculate it, the mole here should be 0.140 mole. And it's the mole of Pb, only about lead. So in 1 mole of lead carbonate, it should be able to give out how many moles of lead. If that's 1 mole, then here it should be 1, right? What if I change the number to like 0.140 here? Then here, the brackets here, it should also be 0.140, right? Which represents that in 0.140 of lead, we should also have 0.140 of PbCO3, right? Then I will write the number of PbCO3. I should write the mole. The mole of PbCO3 equals to 0.140 here. If we have the mole, can we calculate the mass? Remember, mass is the mole times molar mass, right? So here we can use 0.140 mole times the molar mass should be 207.2 plus how many carbon? Only 1 carbon, right? 12.0. How many oxygen? 3 oxygen. That will be 3 times 16.0 gram per mole. So the mass here would be 267.2 gram per mole. And then if we times it all together, this one would be 37.4 grams. This is the mass of PbCO3. If we have the mass of PbCO3, and we have the percentage above, right? The percentage here is like 68% of lead carbonates. Can we calculate the ore, the mass of ore? So let's recall the percentage by mass, that formula. It's the number of X times the mass, relative molecular mass of something, and then divided by m of compound, right? Times 100. So in this example, the end of the compound, it should be the ore, right? And here is like the number of PbCO3 times the mass of PbCO3. It will be this. So now we know that the thins here all together, I've already calculated 37.4. And we know that the percentage on the left should be 68. Can we calculate the mass of ore? Alright, mass of ore here. We move, like, the right side is divide, right? If we move to the left, then it will be times. And then we'll put 68% to the right, then it will be minus. So it will be divide. This one, these two are actually change position here. So we can write mass of ore equals to like 37.4 divided by 68%. And times 100% here. So these two percentage, they should be able to eliminate each other out. Then we will only have to write 0.68 here. Okay. If we have this equation, type in your calculator. This one, we should get an answer of 55.0 grams. This one is belong to which choice? Yes, choice T here.